Hey kids, it's Mrs. Davis from Happy Place to Grow. I'm here in my learning corner, and as you can see, it's still the month of March, so there's still time for some fun March learning activities. I'm glad you could join me today. I think the activity that we do is going to be a good one for some teamwork, so I'm going to invite you in to help me out as we do some March math. Now, the name of the math that we're going to participate in together today is called probability math. Yeah, the possibilities are going to be really interesting. Now, probability math, what does that mean? Well, it simply means how likely or how often something could happen. And when you are thinking about the outcomes of math, there are definitely some things that you can do to help you make really good guesses about how things are going to turn out. Now, before we get started in this fun game, we need to know some important math words that go along with probability math. So let's get a little bit familiar with our terms. Here we go. First of all, there's less likely. Less likely means it probably will not happen. Let me show you this card that I have. So there are two colors. Just say these were chips in a bag. I've got 3 green and 4 red. It's less likely that I'm going to choose green. Do you know why? Right. There's only 3 green and 4 red. So it's less likely that I'm going to choose a green one out of the bag than the red because there's more red. All right, let's keep going. This one's pretty similar to the last one. It says least likely, least likely. Let's take a look at this card. If I have 3 different colored chips in here, red, green, and purple, the chance of choosing a purple, it's going to be least likely I choose a purple one out of that bag because there's 4 red and 2 green and there's only 1 purple. So again, it's probably not going to happen. Least likely. All right, let's keep going. I like this word, impossible. That makes it pretty easy when you're making a guess. That means it can't happen. It's impossible. And when we're thinking about colors in a bag, chip colors in a bag, if I have red, green, and purple chips in a bag, but no blue, it would be impossible for me to choose a blue chip out of that bag because there are none. That makes the guessing pretty easy, right? All right, let's keep going. Equally likely. Now, equal means the same chance. So both, if you're comparing 2 colors, both have the same chance of happening. There's an equal chance of choosing one or the other because there's an equal amount. Let's take a look at this card. This one has 3 colors, but if you look at it, there's 3 purple and 4 red. So if I'm choosing out of this bag, I have an equal chance of choosing red or purple because there's the same number of each color in that bag. All right? There's a lot of terms that go with probability math. This one's a good one too, certain. Certain means it will happen for sure, 100%. Let's take a look at our learning card. Chips in a bag. If they're all blue, then it is a for sure, it's certain that I'm going to pull out a blue one because there's no other color in there. All right, we're almost done with our terms. More likely or most likely. Okay, so let's take a look at what that means. It probably will happen. It's not 100%, but it probably will happen. Most likely, most often, the chance of choosing red, if these were chips in a bag, you would most often choose the chip color red. Yeah, you guessed it, because there's more red than the any of the three colors, there's more red. So it's more likely that you're going to choose a red out of there if you keep going in the bag and putting the chips back in there because there's more red chips. All right, now let's play our game, and we're thinking about those terms: less likely, most likely, impossible, certain, equal chances. All right, the name of this activity is called Spinning for Gold. Now, I've got this little spinner here at my house. I want you to participate by helping me make predictions. So we've got a circle shaped spinner, but it's sectioned off into different pieces. So this section, if you can see the lines, there's a shamrock in it. And then this tiny section, pot of gold. And then on this side of the spinner, we have two pieces sectioned off, rainbow and harp. Okay? So if I'm thinking about this spinner and I'm thinking about probability, can you guess if I make spins, can you guess how often I'm probably going to spin the shamrock? Probably a lot because, well, did you guess? Yeah, because it has a really big section, and that spinner's most likely, more often than not, going to land here. However, this side is a big section too, but it's sliced into two equal pieces. So that's a big section, a big side of the spinner. So I'm sure the spinner arm is going to land here or here, maybe the same number of times, but it'll go on this side a lot because that side is a big section. And then if we're thinking about our probability terms, it's not impossible, but it's least likely that it's going to land on the pot of gold because it's a small section. So here's what we're going to do. I have this little sheet here, and the sheet says that we're going to be spinning this spinner 20 times. I'll spin at home, and we're going to do some predicting before we get started. Predicting means we're going to make a guess, and we're going to be thinking about the spinner and how it's sectioned off. So at the top here of this sheet, I have my 4 symbols that are on the spinner, and then I have the word predict, and then I have those terms. So I'm going to grab a green marker, and I am going to read the prediction question or statement, and then we're going to circle off what we think is going to happen in 20 spins. First one says, predict which item the spinner will most likely stop on in 20 spins. So do you think the spinner is going to stop on the shamrock, the harp, the rainbow, or the pot of gold? Most often, or most likely, where is it going to land if we spin it 20 times? Now, let's look at our spinner again. I'm thinking it's probably going to land on the shamrock, most likely. Again, we're just predicting, we're just guessing. So I'm going to circle the shamrock. Okay, you make your prediction. Okay, I'm going to do 20 spins. The next one says, predict which item that the spinner is least likely to stop on. That means it's going to have the least stops. Now, we looked at our spinner and we saw that the section with the pot of gold was the smallest. So I'm going to make a good prediction based on the size of these spinner sections. And I'm going to say, I think it's going to be least likely to land on a pot of gold. What do you think? That doesn't mean that it will for sure, but we're basing our information on the size of the sections. So that's probably a pretty good prediction. Next, it says, predict which two items the spinner will equally land on when it stops in 20 spins. Okay, so thinking about our spinner, and we know that this side is a big section, but it's divided into equal spaces, this half, into two spaces that are equal in size. So I'm probably going to make a good prediction if I say rainbow and harp. So I'm going to go ahead and circle the rainbow and the harp. Now comes the spinning fun. So down here, we're going to keep track of how many times we spin each item. I'm just going to put a little check mark, and then you can help me count the number of shamrocks, harp, golden harps, rainbows, and pot of golds that we spin. Okay, here we go. Let's get started. Okay, I'm going to spin. I'm going to go ahead and put my spinner right here, just so, and I get kind of wild with my spinning, so I'm going to put 2 magnets here. All right, here we go. Oh, it was the harp. So I'm going to put 1 check mark for a harp. But you know what I was thinking? I might better hold the spinner. I thought that was a good idea, but as I'm spinning, I'm thinking about gravity, and I'm thinking that spinner might get pulled down. So here's what I'm going to do. I'm going to spin this way so that we have a really accurate spin, and then I'll hold it up and show you. Because it might, because of gravity, keep pulling down there. All right, I'm glad I thought that through before we kept spinning. Here we go, spin number 2. Oh my goodness. I'm just going to hold it where it landed. I'm surprised. Pot of gold. So I'm going to go ahead and check for that. Again, this is, probability math, and it's what might happen, could happen, the possibilities. So pot of gold, check. So far we have 1 harp and 1 pot of gold. Okay, let me spin again. I'm going to lay it flat because I think that would be the most accurate way to spin. Although I'd like you to see it. I will show. Whoop. Rainbow. Again, we kind of predicted that there would be an equal amount. And so far, that's our outcome. Now remember, we're doing 20 spins. So I've got 3 spins already. How many more do I need to get to 20? Do you know? Yeah, that's right, 17. 17 and 3 equals 20. All right, here we go. Spinning to win, a pot of gold. Ah, okay, that makes sense. Shamrock. Check, check. So far, we're at an equal number of spins. We've had 4 spins and 4 different symbols of St. Patrick's Day. Spinning again. I'm on the 5th spin. Oh, the luck of the Irish, and it goes to the shamrock. You have to do several spins to kind of see where the probability terms kind of balance out correctly. Okay, that was a shamrock. So we've got 2 shamrocks, 3 for the others, 5 altogether. Spinning. Ooh, another one for the harp. And that makes sense because that is a big section on that other side. So 2 harp, 2 for the shamrock, 1 for the rainbow, and 1 for the pot of gold. 6 altogether. 6 minus 20. That means I have 14 more spins. Let's see, here we go. As predicted, shamrock is kind of moving ahead just a little bit. Okay, that is my 7th spin. 13 to go. When I add a spin, I subtract my number of spins to go. Ah, interesting. Harp again. So we have 3 harp, 3 for harp, 3 for shamrock, 1 for rainbow, 1 for pot of gold. Let's keep on spinning. Dun, 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 dun. Aha! And I promise this is exactly what's coming up. Shamrock it is. So 4 versus 3 versus 1 and 1. Okay. Spin again. Ha! That is so funny. Harp. They're having a contest, the shamrock and the harp. So I've got 4 and 4, that's 8. And then 2 more. 8 plus 2 is 10. So if I'm at 10 spins, how many spins do I have to go to get to 20? Well, right. 10 plus 10 is 20. So 10 more spins. We're halfway there, right? What do you think it's going to be? Did you say shamrock? I'm thinking it's probably going to be shamrock. But it's been a long time since we were spinning and got the rainbow. So maybe it's going to be rainbow. Ah, definitely the shamrock. Remember, in probability, if it's a bigger space or there's more of something, then it's more likely it's going to land on that. Okay. There's our check off. 9 more spins. Ah, it has been a long time since we were spinning and landed on the rainbow. Let's give one for the rainbow. Okay, so we have 5 and 4, 9, plus 1 more is 10, 11, 12. 12 plus what number will get us to 20? Did you say 8? Correct, 8 more spins. Here we go. So far, the pot of gold has been the least likely spin. Oh, that was on the line. So I'm going to spin again, but I'm not going to count that as one of my spins. If it goes on the line, I have to spin again. Shamrock. Shake your shamrock. Spin for a shamrock. All right. Keep going. Count down. We're getting a smaller amount to go. Ah, rainbow. So remember, with the rainbow section and the harp section, they were equally divided. So it's equally likely that we might land on those two, and it's getting close to being equal. So that probability is testing out correctly. Aha! Shamrock again. All right, let's count and see what we have so far so we don't go over 20. So right here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'm at 15 spins. How many more do I need to get to 20? Let me count up and see. 16, 17, 18, 19, 20. 5 more. And so far, in our probability math, it was more likely than any other that we were spinning the shamrock, and that's coming out. These two are about equal, and this one is the least likely that that's coming out to be true. But we have 5 more spins. Let's go. Ah, harp. Again, with probability, it's not a for sure, but you can kind of guess correctly based on the information that you have. Okay, 4 more spins. Here we go. Aha, just ever by a sliver in the shamrock section. Okay, 3 more spins. If I have been counting correctly. Ah, rainbow. I actually moved that, but it was the rainbow. promise you. I would not do you wrong on that. Okay, let's do a check and see what our total is so we don't go over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And I know 19, 20, 18, and 2. I have 2 more spins. Here we go. Aha. Harp. 1 spin to go. See what we've got here. Aha. Final spin of the game, Shamrock. Yeah. All right, let's tally up, let's add up and see what our totals were for each. So if I add up the Shamrock, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 Shamrocks of the 20 and harps, 1, 2, 3, 4, 5, 6 harp spins and 4 rainbow. They were pretty close, not equal, but pretty close as they could be. And then finally, our pot of gold, our least likely because it was the smallest space. So as I'm thinking about the outcome of this activity with our probability math, we predicted, let's go back up here and check. I said, and I know you probably said this too, we were predicting that we were more likely, most likely, we'd probably spin out the Shamrock because that was a really large section on the spinner. And then we said least likely, pot of gold, although we wish we could spin the pot of gold more often because it is a pot of gold, because it was the smallest section, and that outcome was correct. Only 1 time did we spin that. But you know why? The section was very small, so it's least likely that it's going to land there. Smaller section, least likely. See how probability, even though there could be lots of possible outcomes, there are some ways you can kind of narrow those options down by using your information. All right, now the next thing we said equally likely. These two were pretty equal, although the harp, we did spin that more often, but they're pretty close. These two were the closest in being equal. That came out correct. So as we're thinking about possibilities and math, it's always fun to make our guesses, what we think might happen, but we can, as mathematicians, use information to help us make more accurate predictions about possible outcomes. All right, math learners, mathematicians, I hope you enjoyed working with me on our March probability math activity, spinning for gold. Now, this is something you can do at home. You can get some items, put them in a bag, and pull them out 20 times. You can create a spinner and section it off. You don't have to put March symbols. You can put anything you want. Have fun with probability math. Keep exploring all of your possible options with math learning. And as always, until our next time together, have a good one.